Hello students. In this video we will be looking at a few of the steps in the McDonald's French fry fourth lab assignment. So this is located on Blackboard. In this lab we will be, let's go here, we will be measuring French fries from McDonald's. So you should get some French fries, a small order of French fries from your closest McDonald's. Take them home. Before you eat them, measure them to the nearest millimeter as per your lab assignment here. So basically, if you want to do this in small groups, you can. Eventually though, everyone will be completing their own lab report. The only part that's group part is measuring each French fry. So example right in here, you want to measure your French fries to the nearest millimeter, 8.1 centimeters for example, not all rounded to 8 centimeters. So we're going to look at these French fries. Measure them as carefully as you can. Within the lab assignment, you need to determine if a couple things, if you have any right in here. Broken French fries, do you count those as two separate pieces or as one longer French fry? Is there a way for you to determine that it was broken after being cooked or not? So that's something that may have to show up in your actual Word document for the report. Also, did you count the little tidbits as a French fry or did you not include it? Sometimes you get little things that may not look like a French fry, you're just not sure what it is. If you find some of those, you have to make a decision to either measure it and count it as a French fry or to exclude it, not measure it, not count it as a French fry. Once you have done counting or measuring your French fries, you should probably get 30 or 40 French fries. What I want you to do is open up an Excel document. Oops, I don't need that open. Open up an Excel document, place all your measurements in here. Like this. I have quite a few more because I decided to buy a larger order of French fries just to get a better distribution. Once you have all your French fries measured like that, I want you to go into Blackboard. There's a file called Lab4 Extra Data. I want you to copy these measurements. This is just to ensure that everyone is working with a sample size that is sufficiently large for our purposes. Take that and post it into your Excel data. Now, when you're pasting it, you have to use a paste special function, which is when you right-click, click on paste special, click on values, and that will then only copy over the values, not the formula that's was used to create those actual numbers. So in your lab report, down here, the requirements for the report, basically following in the Word document, cover page, introduction, if you had broken French fries or little things included to outline what they were, your descriptive statistics, graphs, and the first part of the inferential statistics is what we'll look at in this video. So descriptive statistics, meaning those 10 items there, what I've done is I have started that process. I'm just going to copy this into another sheet. So here's my data. Here's that extra data that I want everyone to include, and which gives me a count of 150 French fries, a mean and a median of those values, standard deviation using that function, STDEV, bracket, highlight all your data and close your bracket. Proportion is one that's a different function that we haven't used before. It's a count if function, and it's set up like that. If you can see that, basically says, let's show it like this. right in there. Count if, bracket, highlight all your data. If you have spaces or columns between the data, that's fine. Just highlight all of the data, comma, quotation marks, greater than, equal sign, 8. That's going to count all the French fries that are 8 or more. And then we divide by C18, which in my example is the total number of French fries we have. So this count if function will give you the total number of French fries greater than 8. We divide that by the total number of French fries to give us that proportion. Same thing with the proportion of French fries greater than 6 centimeters. Same process, but also divide by your total number of French fries. So you should get a percentage or a decimal number like that. You can change it to percent if you wish. Percentile, just to review that, is the function is equals percentile, bracket, highlight all your data, comma, and then the decimal format of the percentile. So we want the 75th percentile, so we're going to go decimal 0.75. And we get, these are the descriptive statistics. The mean, let's just highlight the mean, and the standard deviation, and our proportion. These are values that we're going to, and our count of course, we're going to use later on when we do some of the inferential statistics. Once we're finished that, we need to create a histogram. So I have done that. The classes are set. I'm not asking you to do the Sturgis method. Basically the class width is 2, so start at 0 to under 2, 2 to under 4, and so forth. Our bin number, this is something Excel requires in order for us to use Excel's histogram function. If you do get, especially the minimum value, if it's negative, it's just something in my formula that the data that I have, so go and find that negative value of the data you've added and just change it to a positive. So now we go into data analysis. Now once again, if you don't have this data analysis function in the data tab, you'll have to go into Excel options, add-ins, click OK. Oops, sorry. Excel options, add-ins, click Go. Make sure the first one it has a check mark on it, and then it should work. You should have this data tab right there. So we're going to go into data tab, histogram, highlight all of our data, including the new data we have, the extra data that we added, the bin numbers, and most importantly, a chart output. And it will create one right there. Remember always to delete that last row, whatever row number that is. We don't need that legend there. And let's format the data series. Let's get rid of that gap. We can add data labels if you want. And then one requirement in the Word report is to comment on the shape of the distribution that you created. Now my shape of the distribution is normal-ish. We seem to have perhaps a little bit too much in this column here. I'm just going to go back into here, grab my classes, copy that into my data table, widen that. Make it so your histogram may look something like that. I have other examples I've worked on. The histogram looked very normal in terms of a normal distribution. So where are we in terms of our lab? We have completed the descriptive statistics. The graphs says here the first class should be 0 to under 2. We've created a histogram, comment on the shape. The last little bit we're going to do in this lab video is look at inferential statistics part A for the first 3. We're going to develop a confidence interval for the mean of a length of a French fry at 90%, then at 95%, and then a 95% confidence interval for the proportion of French fries greater than or equal to 8 centimeters. So look back at our statistics. We have these key values here. We have 150 French fries. We have a mean length of 6.8 and a standard deviation of 2.457. Okay, let's calculate our first confidence interval. Let's go to our whiteboard. Make some more room. So our confidence interval for the mean, 90% confidence interval. 90% confidence interval for the mean length of a McDonald's French fry. Based on our descriptive statistics, we know that the average is 6.8 centimeters. We're going to develop a margin of error. Margin of error is based on a t value, not a z value. We have to use t because this value here is not known. If that's not known, we have to use a z value or a t value. In order to find the correct t value, we can go to this file, finding t and z. I've placed that on the blackboard. We want a 90% confidence interval. Sample size is 150. Our t value is 1.655. So go 1.655. Our standard deviation is 2.457. That's from my descriptive statistics, and we're going to divide that by the square root of 150. So a 90% confidence interval is 6.8 plus or minus 0.33. We'll do the same thing for a 95% confidence interval. Let's change colors. 95% confidence interval. Oops, what am I writing there? 95% confidence interval. 6.8 plus or minus. We're going to use that finding t and z value. 95% confidence interval gives us a t value of 1.976. 1.976. Standard deviation 2.457 divided by the square root of 150. Running out of space here, we know that our confidence interval 6.8 plus or minus 0.4. The last confidence interval we're going to build is a confidence interval, 95% confidence interval for the proportion. And sorry about my handwriting there. The confidence interval for the proportion is p bar plus or minus a z value divided by the square root, multiplied by the square root of that. So our sample data gave us a confidence interval, a sample proportion of 34%, so 0.34. We know that a 95% z value, we can find it here as well, is for 1.96. Doesn't matter what the sample size is. So we're going to use 1.96 multiplied by 0.34 times 1 minus 0.34, 0.66 divided by 150. So it's 0.34 plus or minus 0.076. So about 34% plus or minus 7.6%. For your lab requirement, what I would recommend is you can do the confidence interval calculations on paper, but what I would recommend to include it in your lab report is, let's go back to that first confidence interval we calculated, confidence interval for the mean length of the French fry. We have, this is our interval. What I would recommend is telling me the key values that you used. I may not necessarily see those in the actual calculation. You don't have to include the calculation. You don't have to show your work for this part, but I would require you to give me those 4 values. So in your lab report, this is your confidence interval. Your confidence interval is based on those 4 values you have right there.